we're going to talk about another algorithm. This time we're talking about generic searching algorithms. I don't have a fun name for this. It's just an algorithm about searching. So what does that mean? We're going to have code where the user enters a series of numbers, and we're going to ask some questions about the numbers that the user is entering, and we're going to search this data for the answers to those questions. So the kinds of questions we might ask is the value x in this series of numbers? So x would be a number, right? And so we're asking, did the user type the number 7 in this series of numbers? Yes or no? Or how many times did x appear in this series? How many times did the user type the number 7? What is the largest or smallest value in this series? So they type a bunch of numbers. What's the biggest number they typed? Or what's the smallest number they typed? And how many values are larger or smaller than x? How many numbers were bigger than 100? How many numbers were smaller than 42? Those are the kinds of questions we can ask about a series of numbers, and the way we solve that is using a searching algorithm, an algorithm that will search the data for the answer to these questions. This is what the algorithm looks like in general. So we would create a variable to store our answer. So the particular question is going to be true or false. It'll be a Boolean or it'll be a number, so an int. We will iterate over all of the values. So that means we're going to use a loop to loop over all of the values the user inputs. We will get the next value. So it's part of the iteration. They're going to enter a number, so we have to get that number so we can do something with it. We will check the number to see if it meets whatever requirement this particular question is asking us to meet. And then we'll update our answer if it's appropriate based on that check. So this is the general algorithm, the idea, and we're going to convert this into code so we can solve these problems in Java. So specifically, these pieces inside the iteration, what's that look like in code? When we get the next value, we're going to store it in a variable. So this is going to be some sort of assignment statement. When we check each value, whenever I say you need to check something, that means you're going to use an if statement. If statements are what we use to check data to see if it meets some requirement. And then updating the answer, this is another assignment statement where you're going to assign a new value to the answer based upon the results of this check. And now we're going to walk through this algorithm. You can see it above me. I wrote the same algorithm. And we're going to kind of step through this and translate each line into code, not necessarily in order. You'll see it. It's going to make sense, hopefully, the order we go in. But so my first question is, or the first thing we're going to do is iterate over a bunch of values input by the user. So that's the first step of implementing this algorithm. We have to have the user type a bunch of data. So here's how we're going to do that. To get data from the user, we need a scanner. So I create a scanner variable. I call it user here, and new scanner system.in. And then we use a while loop, because if we're going to iterate, we're going to use our loop. The condition we're going to use is has next int. So while user, the scanner, has another int, it's going to prompt the user to type something. They have to type a number. Then this loop will keep going. So as long as they're typing numbers, this loop is iterating. Then we're going to get the next value. So getting the next value, it means we're going to call user.nextInt. That's the scanner method that gets you the number that they typed in. We assign that to a variable. I'm calling it value here. And now we have value. So now we can use that to do something, the next steps in our algorithm. The next thing we need to do is check each value to see if it meets the requirement. So that means this is our value. Value is our value. And we're going to check it to see if it meets our requirement. So we're going to use an if statement. If some condition is true, if we've met our requirement, then we're going to do something. So to figure out what the condition is, we have to know what question we're trying to answer. So I'm just going to pick one. We're going to be answering the question, is the value 7 one of the numbers? So the user's typing in numbers. We want to know, did the user type the number 7 ever in this series of numbers? Excuse me. So to solve this problem, to solve any problem, we need an answer. So this happens before the loop. We have to create an answer variable. So I'm going to call it answer. You could call it whatever you want. I'm calling it answer because that describes what it is. We're going to assign it a value, and then we have to declare the type of it. And what these question marks are going to be, again, depends on the particular question you're trying to solve. So they're kind of blanks you have to fill in based on the particular question you're solving. So you have to ask yourself, as you solve a problem, what is the type of this answer variable? So I want you to think about it. What is the type that we're going to assign, or we're going to declare answer to be? Go ahead and just call it out. Just say, what do you think the type is? Exactly. The type of answer is going to be Boolean, because for this particular question we're trying to solve, did the user type the number 7? The answer to that is yes or no. Yes, the user typed the answer 7, or no, the user did not type the answer 7, or type the number 7. So since it's a yes or no answer, it's going to be a Boolean. The next question you have to ask yourself is, what is the default value? So what value am I going to assign to this variable before I've even looked at what the user typed in? The way to figure out the answer to this is you have to think, what if the user doesn't type any numbers in? What should the answer be, true or false, if the user never types any answer or never types any numbers in? So remember, the question is, did the user type the number 7? What would the answer to that question be if the user never types anything? That's the default value. So what do you think that is? Go ahead and just tell me. Exactly, yeah. The default value should be false. Because if the user types no numbers in, then the user did not type the number 7, so the answer would be false in that case to the question we're trying to solve. And this is the question you have to ask yourself about a problem to figure out what these values would be, the type of answer and the default value. So now we're back to the check statement. We want to check each value to see if it meets the requirement. So we've got our if statement that's going to check the value. The to see if it meets the requirement part is the condition. So what condition are we going to use? What Boolean expression do we put inside the if statement that's going to ask the question, is the value 7 one of the numbers? So think about that. What do you think we're going to write there? It's going to use the variable value because that's the value that the user typed in. So what are we going to compare that to? What do you think? Yeah, we're going to compare it to 7 because that's what is the value 7 one of the numbers? Is the value equal to 7? If the value is equal to 7, then yes, the number it was one of the numbers they typed in, right? That's clearly what it's saying. So that's our condition. And again, that's something that's going to be different for every problem you solve because that's going to be the core of the problem. What am I checking? How am I checking it? The next thing we're going to fill in is the part where we update the answer if appropriate. So answer is our variable with the answer. We're going to update it based on this condition. So if the value is 7, what should we change the answer to? We're going to assign a value to answer, but what value are we going to assign to answer? If the user has typed a 7, what should the answer to our problem be? It's got to be true or false because the answer is a Boolean. So what do you think? Exactly, yeah. Answer is going to change to true because if the user has typed in 7, that means the answer to this question, is the value 7 one of the numbers, is yes, true. True, the user did type 7. So we change our answer to true. And that is it. This code will answer the question, is the value 7 one of the numbers that the user typed in? It's going to iterate over as many numbers as the user types. And if one of those numbers is 7, it changes the answer to true. And if one of those numbers is not 7, then the answer remains false, saying that they didn't type in that answer. So this is how you use a searching algorithm to solve this one particular problem. But like I said before, there's a bunch of different kinds of problems. And in fact, there's a more generic version of this problem, which we talked about, is the value x in this series of numbers. So instead of asking, did the user type 7, we could just ask, did the user type X for some value of X that would have been set somewhere else in the code? So what would we change in this algorithm here, in this code, to solve this version of the problem? Is the value X in this series of numbers? Think about that and let me know. Exactly, yeah, we just changed the 7 to an X. That's it. So if the value is equal to X, then we change the answer to true because that means the user typed X, assuming that X has been declared somewhere else in the code and has some value. What about the question, how many times does X appear in this series of numbers? So instead of saying, did the user type 7, we're asking, how many times did the user type 7? Or in particular, how many times did they type the value of X, whatever that value is? So what has to change in this code to solve this problem? Think about that for a second. You can go ahead and pause the video if you need a little bit of time, but I will tell you in just a second how correct you are. Very correct. So we need to change the type of our answer because now the answer to our question is not true or false. It's going to be a number. How many is answered with a number. So it's an int, and we assign it the default 0 because if the user never types any numbers in, then the answer to how many would be 0. They typed no numbers, which means they typed no x's. So the answer starts at 0. Then we have to change. Our if statement stays the same, right? We're still checking the same thing. Did the user type in the value x? But what happens if they did? We're no longer changing answer to true. Instead, we're counting. We're saying, yes, you typed in the number 7 again. So we want to increment our answer. So we add 1, we do plus plus to increment the answer by 1. So every time the user types in whatever the value of x is, our answer will get bigger by 1. So that's how you count things. And when this loop is over, when the user stops typing numbers, then our answer will tell us exactly how many times the value x was typed, which is the solution to this problem. So you can see most of this code is the same. The algorithm is structurally the same. We're just changing little bits, the type of the answer, the initial value, what happens if the condition is true. Very subtle changes to solve all these different problems. How about this question? How many values are, we're going to say, larger than x? So again, it's a how many question. We want to know not how many times the user typed in the value x, but how many times did they type a number bigger than x? So what do you have to change in this code to make it solve this problem? Think about that. Yeah, this one's pretty simple. We're changing the condition of the if statement this time. So instead of saying if the value is equal to x, we're saying if the value is greater than x, right? It's exactly what the question's asking. How many values are larger than x? How many values are greater than x? That if statement is the question that we're trying to solve. We're just making the code ask the question. So that's it. This will count how many times the user types a value greater than x. And if you wanted to make it smaller, you would just make that a less than sign instead of a greater than sign. All right, so I skipped one. Let's go back to that one. So what is the largest value in this series? So the user types a bunch of numbers, and I want to know what was the biggest value that user typed. What do you have to change in the code to solve this version of the problem? What is the largest value in this series of numbers? Think about that. All right. There's a bunch of things we have to change. First, the default value of our answer, we're going to default to the first number the user typed. Okay? In this particular problem, to get the largest number in the series, the user has to type at least one number. There's no number that represents no numbers. So by default, the first value the user types is the largest value. So we're going to start there. We're going to change let's look at the last part here. We change what we assign to answer, and we change the condition. So let's read the condition like it's a sentence. If the value the user typed in is greater than the answer, change the answer to the value. That's what that if statement is saying. So if the user types a number that is bigger than the answer, and remember our answer is this is the largest value the user's typed. So if the user just typed a value that's bigger than the largest value we've seen, then change the answer to be this new value because it's bigger than the largest value, which makes it the largest value. And then so 3 changes here, and now we've got code that solves this problem, finding the largest value. And if you wanted to find the smallest value, you would just change that from a greater than to a less than, and the rest of it would stay the same. Because the same principle applies. The first value they type is also the smallest value they've typed, right? They've only typed one number. It's both the largest and the smallest value at the same time. All right, so hopefully that makes sense. I don't know. I can't really ask you. You're going to see this tomorrow. So summary. This is our basic searching algorithm. So you could memorize it, right? Or just try to understand in the words that describe it and how to translate that into code. That's your basic one. It looks at every value. So you use the while loop to iterate over all the values. And then you use some sort of getter method to assign that value to a variable. That's the int value equals user.nextInt. You check to see if that number the user entered is something you're looking for. Does it meet the requirement of the question? And then you change your answer somehow. You update the answer variable based, again, on the question. Sometimes you set it to true or false, or you increment a number, or you change it to a number. That's all going to depend on exactly what they're asking you to solve. And that's it. That's the searching algorithm, right? No more slides? What? Bonus slide? Lucky day. What if we weren't searching through numbers, but we were searching through strings? So instead of the user typing numbers in, they're typing words in. And we want to ask similar questions about the words. Did the user type this word? How many times did the user type this word? So we have to make a couple of changes, right? Because all those scanner methods were specifically, if I go back, for ints. Has nextInt, nextInt, the user has to be typing ints. So we have to change those to be string scanner methods. So has next and next are the scanner methods that check to see if the user has typed a string and get the value of that string. And then instead of using X is what they're typing, I changed to stir. So we're saying if the value the user typed is stir, then change the answer to true. So this would answer the question, did the user type this particular word? Did we find this word in the series of words? Does anything else have to change? Does this look good to you? With your expertise? I don't know. I've been doing this. I don't know what's going on here. Do you think is there a bug here? Probably. It's good to keep your eye open. I make bugs in my slides all the time. And in this case, there actually is a bug, but I kind of did it on purpose here. Remember, when you're comparing two strings, you cannot use equals equals. We talked about that because of how references work. When you compare two strings to see if they're the same, you have to use dot equals. So that's a big thing you have to remember when searching through strings is you're using dot equals instead of equals equals. A very common mistake is to write your code like this with an equals equals. It will compile, it will run, it will not work correctly. It'll never be true because it's checking if these are the same exact word, but you're typing the same letters, but now you've got the word here and the word here. These are different words. If you use dot equals, these are two different words, but it's comparing the letters of them, and it will see that the letters are the same. So that's something to remember when you're searching through words, use dot equals, and when you're searching through numbers, use equals equals. And that is actually the last slide. Way to go. You know a searching algorithm. Gonna stop the slideshow. Oh, smash that like button.